All right, good morning, afternoon, whatever we are at. Today we're going to talk about factoring, where the number in front of that x squared is more than just a 1. So we actually have a number there. And here's the general format that you're going to use to factor these. You'll see it says factoring ax squared plus bx plus c. That's the general formula. And we're going to fill in the box, and this diamond, this x blanks by this way. So put me on pause for a second and write down all of this information somewhere. You'll need it in your notes, and then we'll go on and start factoring. All right, so if we look at this problem, we want to factor this, and again it says this spot in the top left would be the 3p squared, and this minus 5, the c spot goes there. It said make a diamond, or excuse me, a x. We call this diamond factoring, I don't know why. And it says the top of this is filled in, multiply that a x squared or a whatever squared times the c. So this would be negative 15p squared. And in the bottom goes the b, which is negative 2p. Now I want two things that multiply together to give me negative 15. Well, since I want them to multiply and give me a negative number, I know one has to be positive, one has to be negative. But add together to give me negative 2, which tells me the bigger number has to be negative. So factors of 15 are 1 and 15, 5 and 3. The two that work to give me a negative 2 would be 5 and 3. And to be negative 5p and a positive 3p, because negative 5 plus 3 gives me negative 2. But multiply and gives me negative 15. So I will fill those in, and it doesn't matter which order you put those in the box, but you fill those in the box that way. Now, I am going to look across and down for common factors. So if I look across right here, I want the biggest factor between 3p squared and 3p, which is just going to be a 3p. And then right here, I want the biggest factor between the 3p squared and the negative 5p, which is just going to be the p. And now if you look where those two things intersect, those two blue lines, that should be 3p squared, 3p, excuse me, times p, which is 3p squared. So there's how we start out. Now to fill in the other two blanks, like here, I need to have this number times this p to give me negative 5p. Well, it has to be a negative 5. And then if I look in this spot, I know that this number times this number have to give me negative 5. Well, that's going to be a positive 1. And then to double check this, I can look to make sure this 3p times the 1 gives me 3p, which it does. So those are my factors, and it's going to be 3p minus 5. I'm just reading down the left-hand side of the box, or the outside. And then this p, if there's no symbol in between, it's a positive number, so p plus 1. You can double check to make sure your work by foiling or foiling them back out. So outer times outer, 3p squared, and this would be plus 3p minus 5p on the bottom, and then minus 5. We'd combine our middle terms, and we get 3p squared. Hold on, I'll pull this up for you a little bit. Minus 2p, and then minus 5, which is what we started with. So that is how you factor that trinomial. All right, so moving on to the next one. I'll use the same box. So we're doing number 2 now. Oops, actually, let's pull the shade up. So this is a question that we're doing now. And again, in this top spot is this 2n squared and negative 9. And here's my diamond, or my x. First and third term multiplied together gives me negative 18n squared. The middle term goes in the bottom, so 3n. So things that multiply together to give me negative 18. One has to be positive, one has to be negative. Add together to give me positive 3. bigger one has to be positive, that means. Factors of 18, 9 times 2, can't add those up to be 3. 18 and 1, they don't work. 3 and 6, well, those would work. 6n and a 3n. 3 times 6 is 18. I want to add up and be a positive 3, so again, the bigger number has to be the positive. So those two would add up to give me a positive 3. So I will put my 6n and my 3, negative 3n in there. And then common factors, if we look out, across the top, we have the 2n squared and the negative 3n. All they have in common is just an n. And up and down, they would have a 2 and an n, because 2n goes into 2n squared. It also goes into 6n. So I know that 2n times this spot has to give me that 6n. So that has to be a 3. I know this 3 times whatever goes here has to give me the negative 9. So that would be a negative 3. And then double check that this times this equals that, which it does. So my factors here are going to be n plus 3, and then 2n minus 3. All right. Next page, we'll try a couple more. Again, we'll start by making that box, filling in what we know. 3n squared, 4, my x, this is first and last terms multiplied together, 3n squared, and here is my b term. All right, so factors of positive 12n squared, that add up to give me negative 8n. Well, if they're multiplying together to give me a positive number, they either both have to be positive or both have to be negative. If they're going to add and give me negative 8, so I know they're both going to be negative. And what do we have? 12 and 1 don't work. 6 and 2, negative 6n, and negative 2n work. So again, I write them in either order. And I'm looking for filling in here. If we look, 3n and 2n, 3n squared, excuse me, 2n, all they have in common is an n. But if I look up and down, they have a 3n in common. So 3n times n gives me that 3n squared. 3n times some number gives me this negative 6n. Well, that happens to be a negative 2. Negative 2 times this number gives me the 4. Well, negative 2 times negative 2 will give me the 4. And then I will check, but that top one doesn't work. So we have something wrong here. Let's see. Because negative 2 times n gives me 2n, not, or negative 2n, not 2n. All right, I found our error. This was supposed to be a negative. Whoops, sorry, and then I just erased it. This also is supposed to be a negative 2n here. So that would make sense because negative 2 times n gives me negative 2n. So those are our factors. I had it right. I had the outsides right. I just had the inside wrong. So give me a second. I'll make us some room here. All right, so our factors should be this n minus 2 and the 3n minus 2. All right, so let's try another one. In this case, this time we have 5n squared here, 12 here. Now we need 12 times 5, which is 60n squared. That add, so factors of 60n squared that add up to be 19n. So 60 would be what? Let's think of factors of 60 that add up to be 19. I think it would be 15 and 4n, 15, 30, 45, 60, they would add up to be 19, but multiply together and give me 16n squared. So let's put them in, 15n and 4n. Let's see. I need numbers. Here, greatest common factor is just an n. Here I have a 5n. 5n times n gives me that 5n squared in the top left. 5n times 3 gives me 15n. 3 times something, 4, gives me 12. And then 4 times n gives me 4n. So this would be n plus 3 as one factor, and the other one would be 5n plus 4. All right. Here's another couple, and we're going to draw our box. You guys should go ahead and try these. Put me on pause, and then come back and check your answers when you're done to see if you get them. Here's what you should have gotten for your first one. So go ahead and check it, then put me on pause and try the next one. And here's what you should have gotten for number 6. All right, then we are going to start with ones that have a little bit more to them. Let's actually skip number 7 currently. Let's go to number 8, because I want to remind you that we still have this to take into consideration. I can look at those and I see that I can factor something out first. So the first thing I'm going to do is factor a 3 out and rewrite the equation. If I do that, 3 times, because you should factor out the greatest common factor first if you can. So it'd be 3k squared plus 3 goes into 66, 22k. Plus 3 goes into 21, 7. So now this is what I'm factoring. So, sorry, put my box down here. And I am going to just know that my answer is going to have that 3 in it at some point. So I'll have to put that 3 back in there. Sorry, I didn't mean to erase it all. So again, we had 3 and we had 3k squared plus 22k plus 7. All right, and we're going to factor this using the box method. And we know this is that 3k squared, and this is 7. Here's my x. So first and third term, now I'm ignoring the 3 that's on the outside. So this 3 is just going to temporarily get ignored. So I'm taking the 3k squared times the 7, which is 21k squared. And then this spot is still that 22k. Well, the terms are going to be 21k and, sorry, and k. Or 1k, because 1k plus 21k is 22k's. So 21k here, a k here. And now we'll do that. Common factors between 3k and 21k is 3k, or 3k squared, excuse me. And I know this would have to be a k. 3k times something is 21k. Well, that would be 7. And then 7 times something is going to give me 7. Well, that should be a 1. So my 2 factors from this part are going to be k plus 7 and this 3k plus 1. The only trick is we're not done, and that's where kids oftentimes make the mistake. This 3 still has to go down there in front. So this is my factored form. Remember, I have to get back to where I started, and if I would just multiply the binomials, the parts in the parentheses together, I wouldn't get back up to that 9k squared. I would only get 3k squared. So I have to keep that 3 that I factored out with me for the whole time. All right. Again, if you want to keep going, put me on pause and then come back and look at the answers on these. I'll do them both. And here are both of these answers. The first one is right here. There's 3 on the outside, and then n minus 2, 5n plus 3. And then here's the second one. X minus 3 and 5x minus 3 are the two terms. Notice that sometimes we have things to pull out in front, so we can factor out first, and sometimes we don't. In first one, 15, 27, and 6 all have a common factor of 3, but number 10, 5, 18, and 9 don't all have a common factor. So again, sometimes you can pull something out, but you should always check to see if you can. Thanks.